Assalamualaikum warahmatullahi wabarakatuh. I can explain about organic chemistry CHM 207 Chapter 6 Hydroxyl compound, alcohol and phenol. Content about hydroxyl compounds. First, nomenclature. Second is classification, physical properties and acidity. Third is reaction of phenol. Fourth is reaction of alcohol, and next is use. Okay. Reaction of phenol can discuss about reaction with sodium, esterification, halogenation of the ring, and nitration of the ring. For reaction of alcohol, can discuss about oxidation, esterification, halogenation, and haloform reaction, dehydration to form alkenes, and formation of ester Williamson ester synthesis to hydroxyl compounds. Next, about classification of alcohol. Three types of classification of alcohols. First is primary alcohol, second is secondary alcohol, third is tertiary alcohol. First, primary alcohol, OH group attached to 1 degree carbon, example ethanol. Second is secondary alcohol, OH group attached to 2 degree carbon, example is 2-butanol. And 3 is tertiary alcohol, OH group attached to 3 degree carbon, example is 2-methyl 2-propanol. Three types of classification of alcohol can discuss about structure and example. First is primary. Structure is 1R for carbon. For example is ethanol, and 2-methyl 1-propanol. Secondary structure 2R, example 2-butanol or cyclohexanol. 3 is tertiary, is 3R, and example is 2-methyl 2-propanol. Okay, next, nomenclature of alcohol. First is aliphatic alcohol. About is IUPAC system is widely as through the following rule. First is select the longest carbon chain with OH group attached to it. Second is number the carbon atom in this chain so that the one bonded to the OH group has the longest possible number. Third is form the parent alcohol name by replacing the final of the corresponding alkene name by OL. Fourth is number each alkene branch chain or other group and designated its position by number. Example for aliphatic alcohol. First is 2-methylbutanol is wrong because no methyl for the structure. The correct is 2-butanol. Second is 4,4-dimethylpentanol is wrong for the name, the structure, because the structure is 4,4-dimethyl-2-pentanol. Third is 3-pentanol is correct. And next is cyclopentanol. The structure and naming example for aliphatic alcohols. Next is when there are 2 or more OH group present, the name ends with diol, triol, and so on. For example is 2,4-pentanediol. Okay, OH is 2 and 4. This carbon pentane. Okay. Next is example for IUPAC name. First is propane 1,2-diol because OH is 1 and 2 carbon for propane. Next, nomenclature of alcohol. Second is aromatic alcohol, phenol. In most cases, the name phenol is used as the parent names. For example, it's 4-methylphenol is second 3-nitrophenol. Next, for aromatic alcohol, the term ortho 1,2-disubstitute, meta 1,3-disubstitute, and para 1,4-disubstitute of often used in the common names. IUPAC name, for example, is 2-bromophenol. Second is 3-nitrophenol. Third is 4-ethylphenol. Common name, first is ortho-bromophenol. Second is meta-nitrophenol. Third is para-ethylphenol. For the structure about aromatic alcohol. Next, phenol may be monodric, dihydric, and tridric according to the number of hydroxyl group present in the benzene ring. First is benzene 1,3-diol. Second is benzene 1,4-diol. Third is benzene 1,2,3-triol. For phenol. Next, I can discuss nomenclature of alcohol containing two different functional groups. First is alcohol contain double and triple bonds. Use the OL suffix after the alkene and alkyne name. This alcohol functional group take precedence over double and triple bond, so the chain is numbered in order to give the lowest possible number to the carbon atom bond to the hydroxy group. The position of the OH group is given by putting its number before the OL suffix. Okay. For example, two different functional group is first, longest carbon chain, the structure OH group is 5 carbon for structure. Okay. Second is position of OH group is carbon 2 OH group. Okay. Third is position of C double bond C is carbon number 4. Complete names about 4-pentene 2-ol. Next, some consideration. OH functional group is named as a hydroxy substitute when it appears on a structure with a higher priority functional group, such as acid, ester, aldehydes, and ketones. Example is 3-hydroxybutanoic acid is because 3 OH side for carbon C, and second is 2-hydroxycyclohexanone for OH carbon number 2. Main groups. Okay. Decreasing priority. First is acid, ester, aldehyde, ketone, alcohol, amine, alkenes, alkene, ester, halide. Next is I can discuss about physical properties is physical state of alcohol. First is number of carbons. Is simple alcohol is carbon are small for 12 and carbon bigger for 12 is for phenol. Physical form is liquid, colorless is solid, and colorless liquid or low melting point solid. Okay, boiling points. The boiling point of alcohol are higher than those of alkenes and chloroalkene of similar relative molecular mass. For example, relative molecular mass is C2H5OH is 46. Boiling point is 78 degree Celsius. 4 is second is CH3, CH2 and CH3. Relative molecular mass is 4d4. Its boiling point is negative 42 degree Celsius. For third is CH3 is Cr is relative molecular mass is 15.5. Boiling point is negative 24 degree Celsius. Okay, reason is intermolecular hydrogen bond is between the OH group in the alcohol molecule. For example is hydrogen bonding is OROH HOR bonding, hydrogen bonding for structure. Okay, branch chain alcohol boil at a lower temperature, more volatile than the structure chain alcohol with the same number. Okay, next for solubility of alcohol in water. Alcohol with short carbon chain such as methanol, ethanol and propanol dissolve in water. When alcohol dissolve in water, hydrogen bond formed between the OH group of the alcohol molecule and the OH group of the water molecule. Second, the solubility of alcohol in water decreases sharply with the increasing length of the carbon chain. Higher alcohol are insoluble in water. Its alcohol contain a polar and OH group called hydrophilic and a non-polar and the alkyl group called hydrophobic. The water solubility decreases, the alkene group become larger. Okay, next is alcohol with more than one hydroxy group. Polyhydroxy alcohol are more soluble than monohydroxyl alcohol with the same number of carbon atoms. This is because they can form more hydrogen bond with water molecule. 4 is branch hydrocarbon increase the solubility of alcohol in water because reason about branch hydrocarbon cause the hydrophobic region become compact. Okay, now acidity of alcohols and phenols. A is acidity of alcohol. First is alcohol is weakly acidic. Second is in aqueous solution, alcohol will donate its proton to water molecule to give an alkoxide ion is R-O negative. Example is CH3 CH2-OH plus H2O to CH3 CH2-O negative. Positive plus is H3O positive because the acid dissociation constant Ka of an alcohol is defined by the equilibrium. Okay, more smaller the pKa value, the alcohol is more acidic. Ka number is 10 negative 16 to 10 negative 18. Okay, B acidity of phenol. First, phenol is a stronger acid than alcohol and water. Formula is alcohol plus hydrogen to alkoxide plus H3O plus. Okay, for example is phenol plus H2O to phenolcide ion plus H3O plus. For acidity of phenol, phenol is more acidic than alcohol by considering the Reynolds effect. First, the alkoxide ion RO negative. The negative charge is confined to the oxygen and is not spread over the alkene group. This makes the RO negative ion less stable and more susceptible to attack by positive ions such as H positive ions. Second is the phenolcide ion. one of the lone pair of electron on the oxygen atom is dioxide into the benzene ring. The phenolphthalein ion is more stable than the alkoxide ion because the negative charge is not confined to the oxygen atom but dioxide into the benzene ring. The phenolphthalein ion is resonance stabilized by the benzene ring, and this decreases the tendency for the phenolphthalein ion to reach with H3O+. Next is effect of acidity. First is the acidity decrease as the substitution of on the alkene group increase. Reason a more higher substitute alkene group is inhibit sorption of the alkoxide ion. For example, is methanol is more acidic than butyl alcohol. Second is the presence of electron withdrawing atom enhance the acidity of alcohol because the electron withdrawing atom help to stabilize the alkoxide ion. Example is 2-chloroethanol is more acidic than ethanol because the electron withdrawing chlorine atom help to stabilize the 2-chloroxide ion. As alcohol with more than one electron withdrawing atom are more acidic. For example, is 2,2-dichloroethanol is more acidic than 2-chloroethanol. For example of electron withdrawing atom or groups, halogen atom and NO2.
Reactions of alcohol. How many reactions of alcohol are there? There is 6 reactions of alcohol. Reaction with sodium, oxidation, esterification, halogenation, and haloform reactions, dehydrations, and formation of ether. First, reaction with sodium. Alcohol react with sodium to form salt, or we call as sodium alkoxide and hydrogen gas. Based on this equation, we can see that hydrogen atoms that attach in the hydroxyl group to the benzene ring are being left out, and its place are being replaced by natrium. Yeah. So the hydrogen that was left becomes hydrogen gas. Reactivity of alcohol towards sodium. Methyl alcohol is more reactive towards sodium compared to first degree, second degree, and lastly third degree alcohol. Second one, oxidation. In this reaction, the type of product that we get is based on the type of alcohol and reactants we used. If we use 1 degree alcohol and PCC as the reagents, or cuprum or chromium trioxide pyridine as the reagents, we will get from both reaction an aldehyde. But if we used first degree alcohol and we change the type of reagent to acidified potassium permanganate, acidified potassium dichromate, or acidified chromium trioxide, we will got carboxylic acid. For the second degree of alcohol, if we use acidified potassium dichromate, acidified potassium permanganate, or acidified chromium trioxide, we will got ketone. And if we use third degree alcohol, there is no reaction. This is the example of oxidation involving primary alcohol and PCC. 1-hexanol react with PCC will form hexanal. Meanwhile, 1-hexanol, the same alcohol, react with different type of reagents, which is potassium dichromate, acidified potassium dichromate, acidified potassium permanganate, or acidified chromium trioxide, will produce hexanoic acid, which is the type of carboxylic acid. Okay, so now we look at the secondary alcohol. Secondary alcohol, which is 2-butanol. Why is 2-butanol is being considered as secondary alcohol? This is because the carbon that attach to the hydroxyl group also attach to two R group, which is the methyl on the left side and the ethyl at the right side. So when 2-butanol react with acidified potassium permanganate or acidified potassium dichromate or acidified chromium trioxide, we will got 2-butanone, which is ketone. Third one, esterification. To form an ester, the reaction must involve alcohol and carboxylic acid. Okay, from the general equation that we got here, this is carboxylic acid because we can recognize from the functional group here, and this is the alcohol. Okay, yeah, this is the functional group of carboxylic acid. Okay, so the H from the hydrogen from the hydroxyl group in the alcohol and the hydroxyl group from carboxylic acid will combine and form water. Meanwhile, the R group and the R group from carboxylic acid will form ester. So you can see here the only one that being part with the entire structure is hydrogen atoms, and the hydroxyl group also being part from the entire structure of the ethanoic acid. They form water, and the rest will form ester, which is ethyl ethanoate, because we use ethanol as the alcohol and ethanoic acid as the carboxylic acid. If we use methanol as the alcohol, the name will change into methyl ethanoate, just like that. Okay. Esterification also can happen when we use acid carboxylic derivatives because it will not going to change the functional group of ester that will be formed. Okay, so basically this is just the same thing from what we have learned on the previous slide, but the only difference is at the carboxylic acid, where the hydroxyl group are being replaced by chlorine. So the structure of ester is always the same. The only one that changed is only the side product. Before we got water as the side product, now we got hydrochloric acid. Okay, now number 4, halogenation and haloform reactions. Halogenation is the reaction of alcohol with hydrogen halides. When an alcohol undergo halogenation, its functional group, hydroxyl group, okay, will left the carbon change and combine with a hydrogen from the hydrogen halides to form water. Meanwhile, the halogen atom from the hydrogen halides will replace hydroxyl group position at the carbon chain. Okay, so what is the common examples of hydrogen halides? The common example is hydrochloric acid, hydrobromic acid. Okay, so the reactivity of hydrogen halides towards alcohol. So hydroiodic acid is more reactive toward alcohol compared to hydrobromic acid? The least reactive is hydrochloric acid. From the alcohol side, the third degree alcohol is more reactive toward hydrogen halides compared to the second degree and the first degree alcohol. Haloform reactions. The haloform reaction is a reaction of alcohol involving methyl ketone to form haloform. Okay. The example of methyl ketone that we use is thionyl chloride, SOCl2. This is the alcohol. This is our methyl ketone, which is thionyl chloride. The only one that changed is the functional group of alcohol, which is hydroxyl group, because the position of it's getting replaced by the chlorine, okay, to form alkyl halides. And here, the side products, we got sodium dioxide and hydrochloric acid. Dehydration. Okay, dehydration is a type of alcohol reaction that will transform the alcohol into alkene. In any formation of alkene, it must follow the Schatz rule. What Schatz rule have said? The Schatz rule said that the reaction of alkene would favor the formation of C double bond C at the carbon that have many more substituent attached to it. Yeah, so we can see here, this is the alcohol. It's react with concentrated acid sulfuric acid. So the hydroxyl group will disappear and form water, and there will be the formation of C double bond C. But where the C double bond C is going to form? This is where the Schatz rule play its role. Okay. So here we got 2-butanol here. So after going through dehydrations, it will yield two types of product, 1-butene and 2-butene. Why 2-butene is being said as the major product? This is because the C double bond C at 2-butene have many more substituent attached to it compared to the 1-butene. Okay, this is the substituent. 1, 2, 3, 2, 3. This is the only substituent, only this, and this, and this. So 2-butene is the major product. Reactivity of alcohol towards dehydration. Okay. The third degree alcohol is more reactive towards hydrogens, towards the reagent of dehydrations compared to second degree alcohol and first degree alcohol. What is the reagents for dehydration? The reagents for dehydration is concentrated sulfuric acid, phosphoric acid at 160 degrees until 170 degrees Celsius. And third one is the vapor phase of dehydration created by the heating of aluminium trioxide. The second one is the sixth one is formation of ether, which is Williamson ether synthesis. Okay, the formation of ether involves the formation of alkoxide ion. Okay, so in order to form an ether, we must first form alkoxide ion. How to form an alkoxide ion? Alkoxide ion can be formed by adding natrium, sodium, potassium, or potassium to an alcohol. So, when the alkoxide ion is ready, it will attack the primary alkyl halides. If the alkoxide ion attack non-primary alkyl halides, there is no ether formation. The one that will be formed is alkene. Okay, this is the example of formation of ether. We got our basic alcohol, we got ethanol here, and the sodium. When we add ethanol and sodium, we will form alkoxide ion. Here, we add the alkoxide ion with alkyl halides. CH3I is alkyl halides. Make sure the alkyl halides is primary, so it will form ether. This is the ether that will form. Okay, how to distinguish different types of alcohol? In those previous reactions I been explaining. So, how to distinguish these types is by using simple chemical tests such as Lucas test and oxidation of the alcohol. Okay, when we use Lucas test, the results is based on the reactivity of the reaction happens. When we put a Lucas reagent into a test tube with unknown alcohol, if the unknown alcohol was primary alcohol, there is no cloudiness at room temperature. But if it is secondary alcohol, the solution in the test tube will turn cloudy within 5 minutes. If the unknown alcohol was tertiary, there will be immediate cloudiness. Another types of test to distinguish types of alcohol is the oxidation. Okay, in oxidation, only primary and secondary alcohol that will show reactions toward the oxidation reagents. Okay, we got different type of oxidation reagent. Here we got potassium permanganate and potassium dichromate. If the unknown alcohol was primary or secondary, the purple color of potassium permanganate will disappear. And if we use the hot acidified potassium dichromate, the color of orange of the potassium dichromate will turn into green if the alcohol is primary or secondary. Oxidation only happens in the presence of dilute sulfuric acid. Haloform test to identify methyl alcohol group. Okay, there is two type of haloform that can be used to identify methyl alcohol group, which is iodoform and bromoform. Okay, only ethanol and secondary alcohol that will react with iodine in alkaline solution. Note that only in this condition the iodoform will be formed. How we get to know the iodoform is being formed. Okay, the iodoform is a pale. We know it by its pale yellow solid with characteristic smells. Beside ethanol and secondary alcohol, there is no alcohol will form iodoform. We also can use bromoform.
Next, I will explain about the reaction of phenol. There are four reactions of the phenol. First, we will see the reaction with sodium. Second, esterification. Third, the halogenation of the ring. And the last one, nitration of the ring. Okay, the first one is the reaction with sodium, or we call natrium. In this reaction, phenol will react with sodium and will form sodium phenosides and also hydrogen. Based on the first image that you can see, we just add sodium atom at the oxygen ion. It is because sodium has positive charge and oxygen has negative charge. It shows that it will change place. Positive charge will attach at negative charge and negative charge will attach at positive charge. Next, the reaction with aqueous sodium hydroxide. Actually, it is just same like the above reaction. The different just have hydroxide ion and the result will form sodium phenol and water. Okay, next. I will explain about esterification of phenol. You will probably remember that you can make ester from alcohol by reacting them with carboxylic acid. You might expect phenol to be similar. However, unlike alcohol, phenol reacts so slowly with carboxylic acid that you normally react it with acid chlorides. Now, we look at the example. The example show that we add phenol with acid, carboxylic acid, it will form ester. Third is halogenation. Halogenation is used auto-para reactor. Halogenation of phenol happens when we add liquid bromine or bromine water to an aqueous solution of phenol at room temperature. Decolorization occurs and a white precipitate at 2,4,6-3-bromophenol is formed. In this reaction, no catalyst is needed. Usually, this reaction is used to test the phenol and to determine the mass of phenol in aqueous solution. Now, look at the image. For the example, when phenol react with bromine, it will form 2,4,6,3-bromophenol. Why 2,4,6,3-bromophenol? It is because the reaction use auto-para reactor. Next, phenol react with chlorine. It reacts similarly with chlorine or chlorine water to form white precipitate of 2,4,6,3-chlorophenol. This reaction is called chlorination of phenol. But you must remember this reaction must happen in room temperature. Next, when bromine is dissolved in a non-polar solvent such as tetrachloromethane, it will form monobromophenol. You must separate it two results. First result is 2-monobromophenol and second is 4-monobromophenol. Last one, reaction of phenol is nitration. Dilute nitric acid react with phenol at room temperature will form a mixture of 2 and 4 nitrophenol. But If we use concentrated nitric acid, the nitration of phenol is 2,4,6,3-nitrophenol, or we call pyrric acid. Pyrric acid is a bright yellow crystalline solid. It is used in the dyeing industry and in manufacture of explosives. You can look at the example provided. After I explain about the reaction of phenol, now I will explain a bit about chemical test of phenol. In doing test phenol, we will use iron trichloride and bromine water. First, I will explain complex formation with iron trichloride. When 2 or 3 drops of iron trichloride solution is added to a very dilute solution of phenol, a violet blue coloration is produced. Methylphenol, or we know as toluene, produce a blue color. Okay, next, you can refer color of complex with iron trichloride when react with the phenol compound in this table. Second test of phenol is by use bromine water. When bromine water is added to the concentrated solution of phenol, the bromine water is decolorized. When excess bromine water is added, a white precipitate of 2,4,6,3-bromophenol is obtained.